Hello, fifth graders. This is Chapter 12, Lesson 3. And I would just like to pause for a moment to say I'm proud of you for being here, for being invested in your learning, for checking in on this video and getting to work. Thank you for that, okay? There's some key things to talk about here, one of which is, I'm going to get this little pointer going here. Right here, this word attribute, it just means something you could describe something by, okay? A characteristic, it says here. A characteristic. You could describe things by color or shape, and in this case, we're going to describe triangles by the measurements of their sides and by their angle measurements, okay? So side lengths and angle, the degree of an angle, both of those are also attributes or characteristics that you can describe something by. So if you look over here at the map of the United States, looks like we're more on the East Coast. We have Columbus, Ohio, Atlanta, Georgia, and Dallas, Texas. And this Hammond family goes on a vacation. I think they live in Columbus, Ohio, and they fly to Dallas, Texas. And then from there, they fly to Atlanta, Georgia, and then they fly home, which makes a triangle path in the air. All right? So the question here that I have is, what are the three distances that the airplane flew? Well, it flew 924 miles, it flew 573 miles, and it flew 729 miles. And knowing those distances, how many of these sides of this triangle the air flights made are congruent? Well, if we think back and remember what the word congruent means, the same, we will need to conclude that none of these flight paths are congruent. All right? And using that information, we're going to think about our first way that we can classify triangles, and that is by their sides. All right? So look at this one here. This triangle has two sides that are congruent. They're both 3 inches. The third one is different. When you have two congruent sides, that is an isosceles triangle. And then, if you look here, this triangle has 3 congruent sides. All 3 sides are exactly 3 inches. When you have that, when they're equal, we call that an equilateral triangle, right? And our third example here, none of the sides are congruent. This one and this one and this one are all different, 3, 2, and 4 inches. When that happens, we call the triangle a scaling triangle. So knowing this about how we can classify triangles by their sides, what is the one up here on the U.S. map? Well, they were all different. None of them were congruent. No sides congruent means that was a scaling triangle. Now on the next page, we're going to think about angles based, how we would classify an angle based on classify a triangle based on its angles. So we're going to look at these right here, okay? A really easy way to figure that out is using the corner of a sheet of paper. And I'll start right here with the right triangle. And if you'll notice, it looks just like the corner of a sheet of paper. And this box indicates that it is exactly a 90-degree angle, or the corner of a sheet of paper. Sometimes, let's say the angle is 89 degrees, it can be difficult to visualize, and that's why in math we always put that little box there to indicate this is a 90-degree angle, or exactly the same as a corner of a sheet of paper, which is a right triangle. If you can recognize a right triangle, then you can look at any other triangle and determine if the angles are smaller than a right triangle or larger than a right triangle. Okay, so here's an example. I'm going to take my little fake piece of paper here and put it up to this angle right here, and you'll notice that this angle right here, maybe I need a darker color. This angle right here is much smaller than a 90-degree angle. And when that happens, we call it an acute triangle. It's cute, it's small. And then on the right side of the right triangle, we'll bring this back over, bring it over. That one is acute. And let me turn this around here. And that one is acute. It's smaller than 90 degrees. And what about this one up here? Line it up. Oh, look at that. This one is larger. It's wider than a 90-degree angle. And if one of the angles is wider than a 90-degree angle, then you have an obtuse angle. The other two will be acute, but it only takes one in a triangle for it to be obtuse. So let's check out the pyramid up here. I'm going to move my little sheet of paper up here. Okay. This one is less than the corner of a sheet of paper, less than a right triangle, so it's acute. Let's try this one. That one is also acute. And that one is acute. They're all less than 90 degrees. Okay, so how many angles of the triangle are acute? That was all three of them. How many angles of the triangle are obtuse or wider than the corner of a sheet of paper? None of them. And how many of the angles are right angles, like this right here, like the corner of the sheet of paper? None of them. So what do we have here? We have an acute, there should be U right there, an acute triangle. All right? So triangle and example 2, oh, that's where we're supposed to write it, I guess. Acute on this line here. Okay. So let's practice. We have one triangle that will classify based on its sides, and the other will classify based on its angles. So for the sides, if we look back on the other page, remember we have isosceles, two sides the same, equilateral, all equal, scaling, none of the sides measure the same. So let's look right here. We have a 2, and a 4. So we have two sides congruent or the same. What was that? Let's look back at that word. Please spell this correctly. I know you might have to flip back and forth the pages, but the spelling's right there for you. So please spell it correctly. So only two sides were congruent. So this is an isosceles triangle. Now let's classify by angles, which means acute, right, or obtuse. Oh, maybe I'll grab let's grab this sheet of paper that I made and bring it on down. You could just use a handy sheet of paper that you have. Well, this angle right here is definitely acute. It's way less than 90-degree angle. Let's try the next one. Is this one a sheet of paper? Definitely no, also acute. How about this one? And none of them had that little box. Oh, look, that one I thought was going to be a 90 degree, but look, it's so close to 90 degrees. Right here, if you look at this part, right, oopsie, right, let me tap out of here. Right here, so close, but not quite, huh? So, and that was, again, you should always, almost always, not always, see that box indicating it is a right angle. But that's not a right angle, it's also acute. So we can determine that this triangle is acute based on its angles. All right, so you do have a page to glue in your notes that define acute, right, and obtuse triangles, as well as isosceles, equilateral, and scalene triangles. Glue that in your notes so you can refer to it. You can also refer to these charts in your math book. That's what they're there for. You're learning this. I don't expect you to have it memorized at this point in your life. So refer to it and get good at it on the next page or two. That's all for now. Come talk to me if you have questions or ask a friend.